In this video, we will write equations of asymptotes of hyperbolas. So the hyperbola is the graph right there that I'm highlighting in yellow. Everything else that you see, the dotted lines, they're just for guide. They're not part of the graph. So what's really the graph is the hyperbola highlighted in yellow. Today, we will write equations of the asymptotes. Asymptotes are these two lines that your graph approaches, but will never touch or cross. So we will write the equation in point-slope form. Before we get anything started, I need to finish label the hyperbola. And from the other video where we talked about the parts of a hyperbola, this one, there's this dotted box right there in the middle. And that's kind of important because that's how you can find the distance from the center to the covertex, the distance from the center to the vertex. But without the box, you won't know where the covertex is. And that's what we're going to start out doing before we can write anything. So the way for you to make the box, you start out on the vertex. And then since it's just for guidance only, you're going to dot, you're going to stop right there at the asymptote, and then you're going to turn. You're going to do the same thing. You're going to stop at the asymptote and turn. And do that for all four sides. Okay. Now, from this point, I already know the covertex is right there. And here's the other one. We also know from the other video that the distance from the center to the covertex, that's B. And the distance from the center to the vertex is A. Okay. Now, I have everything labeled. I'm ready to start. So, the point-slope form, most of you remember this like the back of your hand. The difference is, I don't have y1 and x1, but I kind of do. So I will do k, I will use k for y1. And remember, k is from the center, h and k. So I will use k for y1, and I will use h for x1. Now, I will rewrite this point-slope formula that I already know, but I'm going to rewrite with everything that I have here. So I have y minus y1, I will use k. And then I know I will have a line with positive slope, and I will also have another one with negative slope. So positive and negative slope. I don't know what the slope is yet, so leave it alone for now. So x minus x1, I will use h from the vertex. So h right there. Now, we need to be able to identify the orientation, the proper orientation of the hyperbola. So when the hyperbola opens sideways, that is called a horizontal hyperbola because it opens sideways. So in here I have h, k, a, and b. And you're like, wait, I don't really think I need a and b. Check this out. You know I'm going to need the slope here because m is from the slope formula. M that you remember from when you're a little kid, rise over run. So you rise and you run. Rise, run. So it's still rise over run. So, but when you rise from the center to go to the next point over, you go up b units. So you go up b and over a. Go up b over a. If you don't see that, that's fine. But b, if this is a, this is also a. So I'm going over a units every time. So this is a right here. this the same distance. Okay? So my slope in this case is b, being the rise, over run a. Okay, so h, right there from the center. My center is right there at 2, positive 2. So h is 2, k is 2. A is the distance from the center to the vertex. So right there I have 4. B is the distance from the center to the covertex. So right there, 3. Okay, now I have everything I need to write the slope, or to write the equation of the asymptotes, both asymptotes. So y minus k is right there, 2, equals plus or minus, because I have 2 lines, one with the positive slope and the other one with the negative slope. B is right there, 3. A is right there, 4. And then x minus h is also 2. That's all there is to do. Now, if your slope, if this fraction, you had to simplify the fraction. Okay, you already know this, but I just want to remind you. So some of you might struggle with the plus or minus right there. All that is, it's y minus 2, positive 3 over 4 is the slope, x minus 2, and the other equation is with the negative slope. Okay, you don't have to write out both, but that's what this means right there. Okay, it means 2 different equations. Okay, we will do the same thing for the second example, but this time I'm going to pick up the pace a little bit because we already know how to draw the box, and that's what I'm going to do here real quick. Okay, so here's the box, and here is my hyperbola. Since it opens up and down, this is a vertical hyperbola. So B is the distance from the center to the covertex. So that's B right here, B. A is the distance from the center to the vertex. So that's A. Do we have everything? We have A, B. The center is H and K. We already know that. And we just talked about how this is a vertical hyperbola. Okay. So now we know the formula for the point slope form is y minus y1 equals plus or minus m x minus x1. And you know we will use k for y1 and h for x1. Okay, so here is everything I have. A, B, I will do h and k right here, h, k. So h is right there 1, k is right there 0, A is the distance from the center to the vertex, so 5. B is the distance from the center to the covertex, so right there 3. Now, I need to find the slope, rise over run right here. So I rise A and I run B, because B is the same distance right here. This is B. So my slope will be plus or minus rise over run. So the rise is A, run is B. So we're ready. So y equals, just kidding, y minus, I will plug in k for y1, so k is 0. plus or minus. A is 5, B is 3. That's the slope. I'm right here. X minus x1 is h. x1, h from the center is 1. And that's the same thing I have right there. Okay, you can leave it like that, or you can clean up that 0 because it doesn't look pretty. So y equals plus or minus 5 over 3, x minus 1. Last one. Now, I don't have the picture, so how am I going to know if it's a horizontal or vertical hyperbola? Well, we have our cheat sheet right here to where I can figure it out. So notice that the minus is in front of x. So minus is in front of x. That indicates that it's a vertical hyperbola. It could be in this form or this form. Either way, they're both standard forms. Okay? So something else I want to bring up before you go. H is always with x, and k is always with y. H doesn't go first. It will if it's with x. Okay? So now, the negative is in front of x squared. That's what makes that a vertical hyperbola. So, at this point, I know this is a vertical hyperbola. Vertical hyperbola opens up and down. Up and down. Okay. H, K, A, and B. So H, you know the center is H and K. This is H1, K0, A. So we're looking at this one. A is right there under Y. So A is that one. Well, this is A squared. So when you square root it, you get 4. And B is right there. Square root it, you get 6. All right. So here's my equation. The equation for the asymptotes. Y minus K equals plus or minus. Well, I have a vertical hyperbola right here, so I can just use this one because I know the slope is right there. So plus or minus A over B. If you're not sure, if you don't remember, use your cheat sheet right here. Okay, it tells you right there. So A over B, and then X minus H. Okay, we have everything. So Y minus K is 0, plus or minus A is 4, B is 6, X minus H is 1. Now, like I said in the previous example, you have to simplify the fraction, always. And let's clean that up too, because it looks better. Y equals plus or minus 2 over 3, X minus 1. Again, plus or minus, that doesn't exist. It just says, it means that one equation is y equals 2/3 x minus 1, and the other one is negative 2/3 x minus 1. Bye.